Now what we're going to do is we're actually going to take the steps, the 4 steps that we outlined previously, and we're going to use them to solve a problem. Particularly, we're going to use these 2 equations, and we want to find the distance between these 2 parallel lines. Now, how do we know they're parallel? It's the first thing. We have to make sure they're parallel. They're parallel because they have the same slope. They're not the same line because they have different y-intercepts, so they're going to hit differently. That is, I've attempted to graph these. Here's the equation: y equals negative 1/3 x minus 3. Has a negative 1/3 slope with y-intercept of negative 3. Here is y equals negative 1/3 x plus 1/3. Comes across at about 1/3. Didn't plot my points exactly right, but you get the idea. Okay, so that's what we're going to do. And step number 1, what was step number 1? Pick one of the parallel lines and its y-intercept to create an equation of a perpendicular line. Well, I'm going to use this one because I don't like working with fractions that much. And I want a perpendicular line to this, using this and going through this point. So we're going to create an equation of a line that goes through a y-intercept of negative 3, but is perpendicular to these 2. Well, perpendicular slope negative 1/3. If I have a negative 1/3 and I want a perpendicular line, what do? Negate and converse. Contrapositive. I negate it, which means it's going to be positive, and I flip it, so it's going to be a 3. So this equation is going to look like this. 3x, and I'm going to go through the same y-intercept as this, negative 3. So let's graph that line. I'm going to go from this point, my y-intercept is negative 3, I'm going to go up 3 over 1. Up 3 over 1. Up 3. 1, 2, 3, and over 1. So it's going to look a little bit like this. Okay, so let's put that on there and let's graph it on there and draw it so we have some sort of idea what this thing looks like. Okay? So here is a segment that is, or a line that is perpendicular. How do we know it's perpendicular? Because we created it. We made it perpendicular, and it goes through this point. This point is 0, negative 3. Okay, we've got 1 point. Now, what we want to do is we want to find where this collision is. Well, we're pretty sure we know where it is, but let's find that point and make sure we know what that point is. And once we know that point, then we'll be able to take care of this. All right, step number 2. We've got step number 1 out of the way. Set the equation of the perpendicular line and the other parallel line equal to each other to find the point of intersection or collision. So we're going to take this equation we just created, and we're going to take the other parallel line equation, not the one we used with the y-intercept, but this one, plus 1/3, and we're going to set them equal to each other. Why? Because we want to find out where they intersect. We want to find out where they collide with each other. You got 2 cars and they come together and they try to occupy the same space at the same time. We call it a wreck. But in a graph, we call that an intersection. The x and y are the same. We want to find out where they are the same. Well, that means this equation and this equation, let's put this equation up there, y equals 3x minus 3. Those 2 equations are going to be equal to each other at that point, so let's set them equal to each other. Okay? 3x minus 3 equals negative 1/3 x plus 1/3. Now I'm going to do some weird stuff. I don't like working with fractions, so I'm going to get rid of fractions. I can get rid of fractions by multiplying everything by 3. Okay? 3 times 3x is going to be 9x. 3 times the negative 3 is going to be minus 9 equals. 3 times the negative 1/3 is going to be what? Negative 1x. Plus 3 times 1/3 is going to be 1. Alright, look at what I did there. It's just algebra. We did it last year when we were solving and when we were factoring equations. Okay, now, I'm going to add this to both sides. What do I get? 10x minus 9 equals 1. I'm going to add 9 to both sides. Plus 9. I got 10x equals 10. X equals 1. Okay? Pretty simple. So now we know what the x of this point is. Let's go ahead and put it. Now we have to find the y. Number 3, plug the x back into the equation we found. So we're going to plug the x into this equation. Okay? Now let's go up here on the other side so we can take care of it over here. Or I go a little further down. So we're going to plug the x we found, this right here, into this equation. Y equals 3 times 1 minus 3. Well, put that in your calculator and tell me what you get. My calculator in my head says that y equals 0. So we've got a point of that right there. Okay? Now, let's come over here, and I'm going to use a different color so we can tell what we're doing. And we're going to go to number 4. Now, number 4 says, use the x and y you found in 2 and 3. Okay, so that's going to be what? 1 and 0. The point 1 and 0. And with the y-intercept point from number 1. Well, what's the y-intercept point from number 1? Well, it's this thing right there. Okay, so we're going to use these 2 points, and we're going to find the distance between them. What's our equation? Well, it looks like this. Okay, let's make this 1 and this number 2. So our d equals square root of the x of 2, which is 0, minus the x of 1, square that quantity, plus the y of 2, which is a negative 3, minus the y of 1, which is 0. And we're going to square that. Well, what's 0 minus 1? It's negative 1. Squared plus negative 3 minus 0 is negative 3. Put those in parentheses and let's square them. What's 1 times 1? 1 plus what's negative 3 times negative 3? It's that. So our distance equals the square root of 10. Or approximately 3.16. Okay? I'm good with you leaving it right there. Alright? So what is the distance between these 2 lines? From this point to this point, that distance is the square root of 10. Okay? See what we've done? We've taken one of these equations and created the equation of a line that's perpendicular to it using one of their y-intercepts. Showing! And did that. Graphed it. Now, we want to find out where that equation, or that line, intersects the other line. So we're going to set them equal to each other. Find our x, then plug the x back into the equation we created to find our y, and then use those 2 points, original y-intercept point and the one that we found, in the distance formula, to figure this out. A lot of steps. They keep coming. Each step's not difficult, but when you combine them, it makes for a long problem. Study it. You'll have one on a test, I'm sure, sometime. If not here this week, at the end of the semester, or the end of the year. We'll do another one. Okay, let's do another problem. Similar, and just to get some practice. This time we have 2 equations. Y equals 2x plus 2 has a slope of positive 2. It crosses the y-axis at 2. Y equals 2x minus 3 has a slope of 2. Crosses the y-axis at negative 3. These are parallel lines. Why do we know they're parallel? Yes, I know that gets boring to say it. Because they have the same slope. They're not the same line because they cross the y-intercept at 2 different places. And we've attempted to graph those where they are. Okay? Now, let's go through our steps again and see what we come up with. Step number 1, pick one of the parallel lines and its y-intercept to create an equation of a perpendicular line. Well, I'm going to pick this one. Oh, well, why? I just like that one. And we want to create a line that's perpendicular to that. So if I have a slope of 2 and I want to create a perpendicular, okay, what's that perpendicular slope going to be? 2 perpendicular. I'm going to negate and converse it. Well, I can make it a fraction by putting it 2 over 1. Any whole number can be made into a fraction by simply making it, any integer can be made into a fraction by simply putting it over 1. Negating it, we make it negative. Flip it, it turns into a negative 1/2. So the equation of our line will be negative 1/2 x, and we're going to use the same y-intercept right here that this equation uses, plus 2. So we're going to pick this y-intercept to use right here. Okay? All right. So there's our step number 1. Now, step number 2. We're going to take this equation that we created and we're going to set it equal to the other equation of the parallel line. Can't set it equal to the same one, set it equal to the same one, we're going to get y equals nothing. Okay, got to set it equal to the other equation. So let's put both equations down, 2x minus 3. Now why? Simply because what we want to do is we've created this right there, and we're going to go down 1 and over 2. So it's going to be right there, down 1 and over 2. Okay? All right, and so that's what that one's going to look like. Let's go ahead and graph it. So we have it on there. Okay? Believe it or not, you know, our scale on these hand-drawn graphs sometimes isn't quite the same. But that is a perpendicular line, okay? It is perpendicular to that. So that's what that would look like. So what we've done is we have this point right here, and that point is 0, 2. Okay, that's that point. Now what we want to find is we want to find out where this one crosses. We think we know where it is. We think it's 2, 1. Okay, that's exactly where we think it is. But because that comes up 4 and over 2, that would be that a proper slope. And it comes there, we could go with that, but let's find it. Let's use the steps and find it, okay? So we're going to find that point right there. So we've done that, we're going to set these two equal to each other. 2x minus 3 equals negative 1/2 x plus 2. I don't like working with fractions, so I'm going to multiply everything by 2 to get rid of this fraction here, okay? So 2 times 2x minus 3 equals 2 times negative 1/2 x plus 2. 2 times 2x is 4x. 2 times negative 3 is 6. Negative 6 equals 2 times the negative 1/2. 2 times negative 1/2 is going to be negative 1x. Plus 2 times 2 is 4. Okay? Now I'm going to add x to both sides. Okay, so I end up with 5x minus 6 equals 4. I'm going to add 6 to both sides. End up with 5x equals 10. Divide by 5. What do I end up with? 5. I end up with x equals 2. Okay? So we know this point right here, our x is 2. Well, that's what we thought it was. Okay, now, step number 3 says, plug that x into our original equation and see what we get. Y equals. Is that correct? All right, let's see if we get here. Y equals negative 1/2 times 2 plus 2. Well, what's a negative 1/2 times 2? That equals 1. So our y equals 1. Sure enough, it equals what we thought it was, 2 and 1. Okay? So we now have these 2 points so we can put into the formula chart, to the distance formula, and find out what they are. So let's change color so we can tell what we're doing. Step number 4. Okay? We have 2 points. Our original point, the y-intercept, is 0, 2. Point that we calculated, the point of collision, the point of intersection of our other line and our perpendicular line is 2, 1. Okay? Now let's just be different. Use it that way this time. x2 minus x1 squared plus y2 minus y1 squared. Okay? D equals, let's start replacing. The x of 1, the x of point 2 is 0, minus the x of point 1 is 2 squared, plus the y of point 2 is 2, and the y of point 1 is 1. Okay? Equals, what's 0 minus 2? Negative 2 squared plus 2 minus 1 is 1 squared. D equals, what's a negative 2 squared? Well, I hope you come up with this, because if you don't, it would be incorrect. You should come up with 4 plus, and 1 squared would be 1, so the distance would be the square root of 5. Okay, or 2.23, somewhere in that neighborhood. Okay, square root of 5 is good. All right? Follow these. Basically what we did was we created a line that's perpendicular to both of these. Picked a point we already knew. Okay, and then said, okay, if that line goes through that point, then what point on the other line does it go through? Found out what that point was, and then used those 2 points on the distance formula to find the distance.